Hello, my name is Lukas Brunsink, my groupmate is Noah Caddell, and this is our SolidWorks modeling project for drafting 170 Engineering Graphics. It is spring 2024, and our instructor is Dr. Hans Chapman. Thank you, and enjoy the presentation. For our project, we chose to model a gas pump handle. There are a couple different reasons we chose to do this, but the main one was because we thought it would be complex without it taking months to create. We got to work researching and finding reference images, as well as scouting out an actual gas pump from the Los Food station. We drew up a few designs and got to work modeling. The first part we modeled was the nozzle. We figured it would be a good starting point because it is simple and it gave a good reference for dimensions of other parts. The next piece is a custom fastener to attach the nozzle to the main body. Both of these pieces were modeled primarily using extruded boss base and extruded cut features using different profiles. Next we have the main body. This was modeled with the extrude and revolve features and then shaped neatly with fillets and chamfers. We also made an interior conduit for the gas flow by extruding a circle through two ends of the part. Then we moved to the nozzle coupling. This piece is the female counterpart to the nozzle fastener, and it is attached to the top end of the main body. The next two parts are the handle guard and the nozzle stopper. The guard functions as a protection for the handle so as to avoid damage and accidental gas release. Is basically just an L shape extruded, but the curve on the connection point was a little tricky to get right. The stopper is there to prevent nozzle from going too far into the gas tank, potentially causing damage. Now we have the handle. This was made using extrusion and just cleaning up the edges a little with fillets. Oh goodness. Now we have the hardest part to model. The singular circle extruded up 2 inches. This thing was a nightmare. Okay, but in all seriousness, we just needed a small part to actually connect the handle to the body. So this is the exploded view, clearly showing all the parts' relations. Our favorite part is near the nozzle with the fastener. We really enjoyed testing out different designs and thinking of the many ways it could practically work in the real world. Anyway, that's all I have. Now I'm going to hand it off to my teammate Noah to show you the assembly in all of its glory.
Up next, we have the assembly, which we used all 8 parts, and we use aluminum as our material. Majority of our assembly is near the nozzle. Since it's more complex, we use concentric mate the most, since we had a lot more of our parts were circular pieces. Next, our drawing document, which we have in the bottom left. We have our detailed view of the nozzle. It's a lot zoomed in. And then right next to it, we have our section view, which shows the internal and the pipes to show where the gas is coming from. And then right above it, we have the isometric and the top view. Next, we have the pressure and force simulation. We chose aluminum since it's strong, cheap, and safe. For the simulation, we use 2 psi. You may be wondering, we chose that because the internal force of a gas pump is usually around 2 psi. Lastly, we wanted to see if it would withstand normal operations, which is around 45 newtons. For the animation, we show the handle moving for 12 seconds and to simulate the actual function of a real-life nozzle. There would be some type of spring element in the handle to make it return to its normal state. For the animation, we wanted to be a real-life example. Overall, we utilize key engineering graphics skills used such as sketching, SolidWorks modeling, assembly, drawing document, simulation, and animation in the design of the gas nozzle. And we use teamworking skills to communicate with each other. And lastly, we have more references to look at.